Okay, second problem in the sample exam gives us three vectors, says is this set of vectors linearly independent? Prove your answer. Is the set orthogonal? Prove your answer. So let's just work on part A here. We have our three vectors written down. To prove if they're linearly independent, we can just put them in a matrix. Let's say A is the matrix of x1, x2, x3. And so that's 1, 3, 7, 5, 1, 0, 1, 1, 1. And to check if these vectors are linearly independent, the determinant of A not equal to 0. If we find that the determinant of A is not equal to 0, that means they are linearly independent. So that's how we will prove our answer. So we just have to calculate this determinant. So let's expand around the center column since it has a 0 in it. So the determinant of A, starting here in the second position, this will be plus minus, so there'll be minus 5 times what's left here, crossing out the row in column of 5, is 3 times 1 minus 7 times 1. So 3 minus 7. And then plus 1 times, canceling out the middles, we have 1 minus 7. And then minus 0 times whatever, doesn't matter. Alright, so we get negative 5 times negative 4 plus 1 times negative 6. And so that doesn't look like 0, looks like 20 minus 6, looks like about 14, not equal to 0, so our vectors are linearly independent. Okay, so we've proven our answer for number 2A. Number 2B, it says, are they orthogonal? Well, I guess we hope the answer is no, because that's easy to prove. And so let's just test. We can prove that it's not orthogonal by taking two of the vectors, say x1 inner product with x2. If that is not equal to 0, then our set is not orthogonal. And so let's just try x1 and x2, take their inner product. If we get something that's not 0, then we say no, they're not orthogonal. If the first two happen to be orthogonal, you did get 0, then you'd have to try the other two. All combinations would have to be 0 to prove that it is orthogonal. Okay, so x1 is 1, 3, 7. x2 is 5, 1, 0. So if we're going to do the inner product, x1, x2, x1 conjugate transpose times x2, so we get 1, 3, 7 times 5, 1, 0. We end up with 5 times 1 is 5, plus 3 times 1 is 3, plus 7 times 0 is 0. It's 8, not equal to 0, so they are not orthogonal. If any two are not orthogonal, the whole set is not orthogonal. Okay, so that's the answer for number 2.